Hello everyone, welcome back to the new video lecture from the series Python for Data Science. In this video lecture, we will continue with the introduction to NumPy. So, in the last video, we saw that NumPy means numerical Python. Now, what is it? It is a package for data analysis and scientific computing with Python. Now the question is that how it is able to do that? The answer is by using multi-dimensional array object. Along with that, it uses various functions as well as tools to work on this array and speed up the data processing. In this video, we are focusing on creation of the NumPy array from the list and the various attributes of NumPy array. Before creating NumPy array object, we need to install this NumPy library. So using this command pip install NumPy, we can install the NumPy package to our system. What is an array? We have learned in Python, whenever we want to store multiple values in a single variable, we can make use of this array. An array is a data type used to store multiple values using a single identifier, right? An array contains an ordered collection of data elements where each element is of the same type and that can be referenced by its index, or we can say by its position. The entire array is stored contiguously in the memory. So this makes our operations on the array fast. Now we will see how to create an NP array object. So very first step is we need to install the NumPy package to our Jupyter notebook. So as I have already installed that package, so it is giving me a message that requirement already satisfied. After installing NumPy package to our Jupyter notebook, we need to call its allies to our program. So for that purpose, I am writing here import NumPy as np. Now why this step is required? Because every time we want to call this NumPy library, we cannot write down NumPy as a whole. So just we make allies of that and call that NumPy library as np. Now we will create binary array from NumPy. So the command is np.array, and as it is a function, we are giving here round bracket, and here in this command .array command, we are providing a list. So square brackets are required and elements of the list inside that. So suppose I am entering 10, 20 and 30, right? The elements of the list are 10, 20 and 30. Now this list is converted into an array. So we are declaring here one variable named as array1 equal to. So this list is converted into array and stored into the variable array1, right? So it is an one-dimensional array. So we will execute this command and see the output. Here we will write down the name of the variable, and here we are getting the array containing elements 10, 20 and 30. In the same way, we can create a two-dimensional array. So here suppose variable name is array2 equal to np.array. In this function we are providing a list of numbers, suppose 5, then 7, 3. Suppose we are providing here a float number and one string, right? Suppose ABC is the string. So here a list contains of different elements. So we are providing one float element and one string element to this new array variable array2. We'll execute this. So here we can observe that since there is a string value in the list, all integers and float values have been promoted to string while converting this list into the array. Also, we can create a two-dimensional array by making use of nested list. So we will create a two-dimensional array. Suppose name of the variable is array3 equal to np.array is the command. In that we can provide the nested list, right? So this is the outermost list. Inside that I am providing elements, suppose 2.4, 3, right? This is the first element in that. Then next 4.5, 7, and last one is the 0.2 minus 1, suppose. So we can observe the elements of this array, array3. So here we are getting a two-dimensional array. That means there are two columns inside that. Now we will move to the next topic, that is attributes of NumPy by array. So total 5 attributes of NumPy by array we are going to study. The first one attribute is ndarray dot ndim. So this attribute, it gives the number of dimensions of the array as an integer value. So arrays can be of one dimensional, two dimensional, or it can be of n dimensional. NumPy calls this dimension as axis. Thus, suppose there is a two-dimensional array. So it has two axes. The row axis, it is called as axis 0, and the column axis, it is called as axis 1, right? So suppose only one dimensional array is there, so it is having only one axis, axis 0. Then next comes your ndarray shape. So what this command will give, it gives a sequence of integers indicating the size of the array for each dimension, rows or in columns. How many integers or elements are there, that we can find out with this dot shape command. Then next is your ndarray dot size. Now here this dot size command will gives you the total number of elements of the array. How many total number of array elements are there? That means this value will be equal to the product of the elements of the shape. The value we are getting as an output by the shape command, the product of those number will be the output of ndarray dot size. Then next comes your ndarray dtype. So this command will gives you the data type of the element of your array. So all the elements of an array are of the same type. The common data types are int 32, int 64, or float 32, float 64, or u32. Last attribute of NumPy array is ndarray dot itemsize. Now it specifies the size in the byte of each element of the array. Data type integer 32 or float 32 means each element of the array occupies 32 bits in the memory. That is, 8 bits forms a byte. Thus, an array element of type integer 32 has item size 32 divided by 8, that is 4 bytes. Now we will see all of these attributes of NumPy array practically. So we will see the attributes of NumPy by array. So first attribute was ndarray.ndim. So it gives the number of dimensions of the array as an integer value. So we will just recall content of the 3 arrays we have created. Array 1 we have created, these are the content. Array 2 we have created, these are the content of array 2. it is converted into all the string elements. Then array 3 also we have created. So here there are 3 rows and 2 columns. So we can see it as a 2-dimensional array. Now using this ndim command, we will find out the dimension of all of these arrays. So first array is array1 dot ndim. So it is giving you dimension as 1. Then next array2 dot ndim. So again it is giving you as 1-dimensional array, right? So here is only 1 dimension. But for array 3, using ndim command, we are getting here 2 dimension. As there are rows and columns, we are getting here 2 dimension. Next attribute was ndarray.shape. So it gives the sequence of integers indicating the size of the array for each dimension, right? So how many elements are there in each dimension, that we can find out with the dot shape command. So we will execute this command with our created array, array1 dot shape. So here there were 3 elements in a row, right? Then in array2, so there were 4 elements in one direction, and in array 3 we had 3 elements and 2 elements to the column. 3 rows and 2 columns we were having. So this is the shape of array 3. In array 2 there were 4 elements, and in array 1 there were only 3 elements. Now suppose here in array 3, where we have created the array 3, suppose I have deleted this element, the third one element, suppose I have deleted it. Now we will check with the shape command. Now here we are getting 2 elements in one dimension and 2 elements in other dimension. Suppose we will increase the dimension along with this third element. Again one more element I have added here. Now here we can see there are 4 elements in one dimension and 2 elements in other dimension. We'll execute this shape command again. So we see that there are 4 elements in one dimension and 2 elements in one dimension. So this row axis, what we have said earlier, the row axis, it is called as axis 0, which is having 4 elements in that, and axis 1, that is column, it is having 2 elements in that. 2 columns are there and 4 rows are there. So this is what we are getting with the shape command. Now next attribute is your size attribute. So it gives the total number of elements of the array. This is equal to the product of the elements of the shape. So here we will observe the elements of array 1 and we'll use this command array1 dot size. So here we are getting only 3 elements. For array 2 we are getting 4 elements there, right? So if you remember the content of array 2, so there were 4 elements inside that. Then next for array 3, what was the size? Size of array 3 was 8. We have added one more row to that, so total elements become now 8 to array 3. So size attribute, it will give you the total number of elements of the array. Now next attribute is the dtype. So it gives the data type of the elements of that array. So all the elements of the array, they are of same type. So here we will check for array1 dot dtype. So all the integer element were there, so data type is int32. Then for array2 dtype, So there was string we have added, so data type is U31. For array 3 dot dtype, so float elements were added to array 3, so it is giving data type as float 64. Last attribute of the NumPy array is ndarray.itemsize. So it specifies the size in bytes of each element of the array. So we have seen that there were data type integer 32 or float 32. That means each element of the array occupies 32 bits in the memory. So 32 divided by 8, that means 8 bits forms a byte. So 32 bits divided by 8 will be equal to 4 bytes. Same way, each character of Unicode occupies 4 bytes. So 32 into 4. So if Unicode characters are there, it will occupy 128 bytes. So we'll see the item size for each and every array we have created. For array 1, it is of integer type. So we will get here item size as 4 because 32 divided by 8. So it will give you output as 4 bytes. Then next is array 2. It consists of Unicode character. So it will give you 32 multiplied by 4. So it provides you item size as 128 bytes. And array 3, it is of float type. So it gives you 8. So in this video lecture, we have learned how to create an array using NumPy library as well as different attributes of NumPy array. For example, we can find out the dimension of the array using ndim command. We can find out shape of the array using .shape command, size using .size command, then type of the elements of the array using .dtype command, as well as we can find out the item size of the arrays that we have created using NumPy library. So we will study NumPy library in more detail in upcoming lecture. So stay tuned with the channel and don't forget to like, share and subscribe to the channel so that you don't miss the upcoming lecture. So see you in the next lecture. Bye bye.